Hi, my name is Maria Eugenia Sabatini. I'm from Augusta University. Thank you for your interest in this presentation. As you know, chronic pancreatitis causes and sustained inflammation of the pancreas, and by increasing the production of reacting oxygen species among other inflammatory mediators can facilitate the progression of pancreatic cancer. Regeneration can occur as a primary product of the NADPH oxidases. We clearly found that NOX1 inactivated pancreatic stellate cells is involved in both the formation of fibrotic tissue and the production of multi-metalloproteinase 9 in a mouse model of chronic pancreatitis. Because MMPs degrade the basal lamina and in this way facilitate the invasion of pancreatic cancer cells, the objective of this work was to determine the extent to which the NOX1 in chronic pancreatitis activating pancreatic stellate cells facilitate the invasion of pancreatic cancer cells through the production of MMP9. For that purpose, we carry out both in vitro and in vivo studies. Let's start with the in vitro studies. Using the Cytoselect cell invasion kit, we found that the presence of increasing amount of activating pancreatic stellate cells from the wild-type mice with chronic pancreatitis increased the invasion of HPAC cells and MIA-PACA cells, and the lack of NOX1 reduced this effect, and the presence of KIAN cells, pancreatic stellate cells, did not increase the invasion as much. Using quantitative PCR, we found that the MMP9 is downregulated in activating pancreatic stellate cells from the NOX1 knockout mice, and the presence of pancreatic cancer cells did not modify the expression of MMP9. It's important to mention that MMP9 is not expressed in HPAC or MIA-PACA cells. Using the scratch wound invasion assay, we observed the same result. What about in vivo studies? Using an orthotopic mouse model of pancreatic cancer cells, we found that the co-injection of MIA-PACA cells and the chronic pancreatitis activated pancreatic stellate cells from the wild-type mice increased the tumor growth and facilitate metastasis in the spleen, and the lack of NOX1 in activated pancreatic stellate cells impaired this effect. The H&E staining of the pancreas show that the malignant focuses are poor differentiated. The cells has a very prominent rhomboid morphology. The tumors of the pancreas of the NSG mice co-injected with MIA-PACA cells and activating pancreatic stellate cells from the wild-type mice has the most infiltrative appearance of the borders, where the other ones has more circumscribed borders. The Mason trichromy show the low presence of collagen fibers and no abundant democratic reaction. In the spleen, H&E staining show we can observe metastasis only in the NSG mice co-injected with MIA-PACA cells and activated pancreatic stellate cells from the wild-type mice. Using the Mason trichromy staining, low abundance of stroma is observed. Using Western blot, we found that increased level of fibronectin, collagen 1, alpha-smooth muscle-actin, MMP9, and vimentin in the pancreas of NSG mice co-injected with MIA-PACA and activating pancreatic cells from the wild-type mice, and the lack of NOX1 impaired this effect. In conclusion, we will say that the presence of increasing amount of activating pancreatic cells from wild-type mice with chronic pancreatitis increased the invasion of MIA-PACA cells and HPAC cells, and the lack of NOX1 reduced this effect. The NOX1 induced the expression of matrix metalloproteinase MMP9 in activated pancreatic stellate cells. The expression of MMP9 was not affected by the presence of pancreatic cancer cells, and the NOX1 in chronic pancreatitis activated pancreatic stellate cells facilitated the growth and invasion of MIA-PACA cells by remodeling the stroma through the production of MMP9. Thank you for listening. Bye.